James Webb's Living Universe, a 2025 odyssey through time, dust, and cosmic revelation. The cosmos is no longer a silent void of still images and distant flickers. In 2025, the James Webb Space Telescope JWST continues to radically reshape our understanding of the universe, not merely by providing us with sharper snapshots, but by showing us space in motion. Through time-lapse sequences and sequential infrared imaging, Webb has unveiled something even more spectacular than just new cosmic portraits. The visible motion of light echoes, the gradual expansion of dust rings, and the dynamic interplay of forces sculpting space on a grand, ever-shifting scale. This technological marvel is not only a machine of unprecedented vision, it's a time machine, a witness to the invisible processes that fuel the birth and death of stars, and a messenger from the early universe that continues to whisper secrets we never expected to hear. Hashtag WR140 and the dance of cosmic dust. At first glance, one might mistake Webb's latest images of the double star system WR140 for a simple, static cosmic halo. But a deeper comparison between earlier and current images reveals something extraordinary. The universe never truly rests. Structures once believed to be timeless are now seen evolving right before our eyes. Situated approximately 5,000 light-years from Earth, WR140 is home to a particularly rare kind of celestial beast, a Wolf-Rayet WR star. These stars represent a late, stripped-down phase in the life of a massive star. Having shed their outer hydrogen layers through ferocious stellar winds, what remains is a scorching, exposed core rich in helium, nitrogen, and carbon. These stars are so peculiar that they defy traditional spectral classification and exist in a category of their own. WR stars are cosmic firestorms, unstable, powerful, and short-lived, often seen as the final evolutionary stage before a supernova or direct collapse into a black hole. In WR140, every 8 years, the stellar winds from the two stars in the system, one being a WR star, collide. This violent interaction creates expanding shells of carbon-rich dust, each like a smoke ring blown across the cosmos. Thanks to Webb's mid-infrared instrument MIRI, astronomers can now see 17 concentric dust shells, each one representing a past collision and expanding outward at nearly 1% of the speed of light, or about 600 km/s. That's fast enough to travel from Earth to the Moon in just under 2.5 minutes. But perhaps even more fascinating than the speed is the structure. These aren't uniform halos of dust. Webb reveals delicate clouds and clusters, some the size of our solar system, nested within the expanding rings. These ethereal filaments are composed of carbon, one of the most essential ingredients for life and planetary formation. Over time, such dust may drift through the galaxy, seeding the birth of new stars and rocky worlds. In essence, WR140 is a cosmic forge manufacturing the very materials from which new systems, and potentially life itself, can one day emerge. These rings aren't just beautiful, they're vital links in the great chain of cosmic recycling. The universe breakers, galaxies that shouldn't exist. As profound as WR140's revelations are, they pale in comparison to the upheaval sparked by Webb's observations of the early universe, a time when the first galaxies were just beginning to shine. JWST's unmatched infrared sensitivity has pierced the veil of cosmic history, revealing ancient galaxies that seemingly violate the very laws of cosmic evolution. Astronomers were stunned when Webb detected universe breakers, galaxies appearing only 300 to 400 million years after the Big Bang, yet exhibiting mass and structure rivaling that of the modern Milky Way. According to the Lambda-CDM Lambda Cold Dark Matter cosmological model, this shouldn't be possible. There simply shouldn't have been enough time or enough ordinary baryonic matter to form such massive galaxies so soon. At first, scientists suspected a mistake. Perhaps these small red dots were something else, maybe older, closer objects misidentified as early universe galaxies. But careful spectral analysis and redshift measurements confirmed their distance and age. If these were indeed galaxies, then they represented a profound crisis for modern cosmology. But in a fascinating twist, a recent study led by JWST has offered a potential solution that may preserve the standard model, while still rewriting parts of cosmic history. The key lies not in the stars, but in the black holes. Upon re-examining the spectral signatures of these impossible objects, JWST's team found evidence of high-velocity gas movement, up to 1,000 km/s, a characteristic not typical of ordinary star-forming regions, but common to accretion disks surrounding supermassive black holes. These so-called active galactic nuclei, AGN, emit intense radiation as matter spirals inward, heating to millions of degrees. Their conclusion? As many as 70% of these early red dots aren't galaxies at all, but growing black holes. In other words, we were mistaking the brilliant radiation of rapidly feeding black holes for stellar light. This reinterpretation dramatically reduces the required mass of these objects and eliminates the need to assume implausibly fast galaxy formation. Still, questions remain. Why did these AGN disappear after only 1.5 billion years? And why do they emit so little X-ray radiation, despite their extreme brightness? An anomaly that defies our current models of AGN behavior. The mystery of the little red dots isn't entirely solved, but now, at least, we know they're probably not tearing the fabric of cosmology apart. Instead, they may be revealing just how crucial black holes were in the universe's formative years. Cassiopeia A and the glowing echoes of death. On December 23, 2025, JWST captured one of its most haunting and beautiful sights yet, the aftermath of a supernova that exploded in 1680, located 11,000 light-years away in the constellation Cassiopeia. The remnant, known as Cassiopeia A Cas A, is the closest known supernova remnant with a confirmed explosion date, and Webb's view is nothing short of extraordinary. What sets this observation apart is the revelation of light echoes. As the radiation from the original explosion continues to travel through space, it reflects off surrounding clouds of dust and gas, heating them and causing them to emit their own infrared glow. Webb captured these echoes with breathtaking clarity, revealing structures that look like swirling wood grain, branching filaments, and layer upon layer of shock material. According to team lead Jacob Jensen, the level of detail is absolutely shocking. His colleague Josh Peak added, "It's like peeling back the layers of an onion." What we're seeing is the structure of the interstellar medium in 3D, for the first time ever. These leaflet-like structures measure about 400 astronomical units across, a scale that, though enormous to us, is tiny by galactic standards. Their existence suggests that the interstellar medium is not a smooth soup of gas and dust, but a finely textured web, potentially shaped by magnetic fields. The filamentary branches could be magnetic islands embedded in larger magnetic currents, showing that magnetism may sculpt space on much smaller scales than we ever imagined. Liope, a dwarf galaxy with a triple life. One final jewel in Webb's 2025 crown is the unassuming but extraordinary dwarf galaxy Liope, located some 5.3 million light-years from Earth. It contains only a few 100,000 stars, a mere whisper compared to the Milky Way's 100 billion, but it's teaching us something profound about galaxy evolution. Using Webb's near-infrared camera and IRCam, astronomers led by Kristen McQuinn analyzed over 15,000 stars in Liope and reconstructed the galaxy's star formation history. What they discovered was remarkable. Liope experienced 3 distinct phases of star formation. The first burst occurred over 12.6 billion years ago, during the epoch of reionization. Then, it went quiet for 2.5 billion years, only to restart star formation, and continue to do so even today. Only 3 other galaxies are known to show this pattern. Crucially, all are isolated, far from the gravitational interference of larger galaxies like the Milky Way. This suggests that proximity to larger galaxies may suppress late star formation in dwarf systems. Why did Liope ignite a second time? Theories abound. Perhaps it encountered a cloud of gas or drifted near another dwarf galaxy, triggering gravitational instabilities that rekindled its stellar fire. Or perhaps it merged with another small galaxy, providing new material and gravitational turbulence. The final word, a universe more alive than we dreamed. In every image, in every echo, in every whisper of dust and shadow, the James Webb Space Telescope is telling us one story. The universe is alive, constantly changing, collapsing, reforming, and surprising. It's not a museum of ancient light, but a stage of perpetual cosmic drama. From the collapsing hearts of stars to the birth of galaxies and the swirling cauldrons of black holes, Webb has given us something unprecedented. Not just a deeper look, but a living, breathing universe. And this is just the beginning. So, if gravitational ripples of curiosity stir within you, don't just admire the cosmos from afar. Stay tuned, subscribe, and journey further because with Webb at the helm, we're only just beginning to understand what's truly out there.